if I plot velocity on vertical axis and time on horizontal axis, and let's say this is uniform motion. Okay, this is uniform motion. So our object moves with uniform velocity. That means velocity is constant. Okay, so let's take t equals to 0. So at this time, suppose the velocity has this much value. Okay, it has got this much value. Then at t equals to 1 seconds, the velocity will be same. At t equals to 2 seconds, again the velocity will be same. Okay, so the value of velocity is this much only. That means if we plot the graph of velocity versus time, we will get this straight line. The straight line is parallel to the horizontal axis, that is time axis. Okay, and now let's say I want to plot the uniformly accelerated motion. So in uniformly accelerated motion, the velocity will either increase uniformly or decrease uniformly. Okay, so in that case, if the velocity decreases, it is known as uniformly decelerated motion. Okay, or you can say acceleration is negative. Okay, so I will plot velocity on vertical axis and time on the horizontal axis. So this is uniformly accelerated motion. Okay, so the graph of velocity versus time, it will look something like this. Okay, so this is initial velocity, let's call it u. At some time t, let's say at this time t, the velocity becomes v. Okay, or let's call this initial velocity as v naught, velocity at t equals to 0, and then at this time, okay, let's draw perpendicular from this time on the graph. It meets at this point, and from this point I will draw perpendicular on the velocity axis. So the velocity at this time is v suffix t. Okay, so the velocity is increasing uniformly, right? The velocity is increasing uniformly. So how do I find acceleration from this graph? I'm sorry. How can I find acceleration from this graph? What is acceleration? It is change in velocity divided by time, right? So acceleration A is equal to change in velocity, velocity at time t minus velocity at t equals to 0 divided by time. Okay, so if you look in this graph, so in this graph, it is equal to slope of this line. Okay, this acceleration is slope of this line, right? So see, if I draw this perpendicular, so now what will be slope of this line? Change over the vertical axis, which is this much, divided by change over the horizontal axis. Okay, so if I join this point, let's say I join this point, okay, so change over the vertical axis is this much, this is delta v. Okay, this is final velocity at time t minus initial velocity at t equals to 0 divided by change in time. So this much is the change in time, delta t. Okay, so you can say this is v2 minus v1 divided by t2 minus t1. That's how we find out the slope, right? So slope of this line will give me what? The acceleration, the average acceleration. But since the velocity is increasing uniformly, the acceleration is constant. Okay, so that's why we are getting this straight line over here. If you throw a ball vertically upwards, so there is acceleration due to gravity which is acting on it, which is if you throw the ball upwards, the acceleration would be negative, right? It is minus 9.8 meters per second square. If you release a ball from some height, it falls on the ground. Okay, so there is some acceleration acting on it. How much is that? 9.8 meters per second square. So this is the example of uniformly accelerated motion. right? So now what we are going to do is we are going to derive three kinematic equations of motion. So do you know the kinematic equations of motion already? What are they?
Yes, sir.
Yes, sir.
V equals to u plus at, S equals to ut plus half,
80 square.
at square, and v square equals to u square plus 2as.
U square plus 2as.
Right.
Yes.
Okay. But we are using v suffix t for velocity at time t and v naught for velocity at the beginning. Okay. So the equations will change accordingly. All right. So now we have seen here that acceleration is vt minus v naught divided by t. Okay. So the acceleration is given by v at time t minus v naught divided by t, which is slope of this velocity versus time graph. Okay, the straight line, slope of this line. Okay, so therefore now I can take this t on the other side. Okay, so what do I get? A times t equals to vt minus v naught, and therefore I can take this minus v naught on the other side. So I get v at time t, v at time t is equal to v naught plus a times t. Okay, so final velocity is equal to initial velocity plus acceleration multiplied by time. So this is your first kinematic equation of motion. Okay, that's very simple. Next equation, so this equation, it gives final velocity if you know the initial velocity, acceleration and time. Okay, so this is the first kinematic equation. Next equation will give you the displacement. Okay, and what is displacement? Displacement is the area under velocity versus time curve. Okay, so if you see here in uniform motion, this is your velocity, okay, which is constant, and if you take some time t, then now this is velocity and this is time. So if you multiply this side with this side of this rectangle, sorry, you will get area under this rectangle, okay, which is this shaded area. Okay, so your displacement s is equal to v divided by t, because velocity is constant. Sorry, what I'm saying, your velocity is displacement divided by time. Okay, and if you take this time on the other side, so you will get what? S is equal to v multiplied by t, which is, okay, this is v, this is t. So area under this velocity versus time graph will give you displacement. Similarly, now here also, if you take area under the velocity versus time graph, it will give us displacement for which kind of motion? For uniformly accelerated motion. Okay, so now I have drawn that same diagram over here. So here we can apply two ways of finding out this area. So first one is area of a trapezoid, okay, and second one is dividing this figure into,
Area of triangle and area of rectangle.
right. So dividing this diagram in a rectangle and a triangle. Okay, so how much would be this length? So this length is time, right? This length is equal to t, we know. How much would be this length? So this much length is vt.
Vt minus V naught.
It is vt minus v naught, right? This much length is vt, this much length is v naught. So we want to find out this much length. So this much length is vt minus v naught, right? So we can say the area under velocity versus time curve gives us what? It is displacement. Okay, so S is equal to area of this rectangle. Let's call it something. So this point is O, this point is, let's call it what, P, Q, R, okay, and this is suppose S. So area of the rectangle OPQR plus area of this triangle, which is RQS, okay, or QRS, area of triangle QRS, okay, and that can be written as, I'm sorry, so that we can write as S equals to area of this rectangle is this much length, which is time multiplied by this much length, which is V0. So it's V0 multiplied by time, okay, length multiplied by breadth. And what is area of a triangle?
1 by 2 breadth into height.
Okay, so it is half of base multiplied by height, right? So base is equal to time and height is Vt minus V0. So we can write it as half of the height, which is V at time t, minus V0 multiplied by t, okay, which is base. After that, I know that acceleration is equal to V0, sorry, it is Vt minus V0 divided by t, okay. So if I take this t on the other side, I will get Vt minus V0 equals to what? A times t. So Vt minus V0 is equal to A times t, okay, and that I can substitute over here. So what do I get? I get S is equal to V0 times t plus half of At multiplied by t, it is A times t squared. Okay, so this is your second kinematic equation of motion. Okay, this is simple. Let's take second kinematic equation once again. S is equal to V0 times t plus half of A multiplied by t square. And from here, I want to derive the third kinematic equation. So I can do one more thing. I can take t common. Okay. So I have V0 plus half of At multiplied by t. Okay. And then I have V0, sorry, A equals to Vt minus V0 divided by t, or from here I can write At is equal to Vt minus V0, right? And t equals to Vt minus V0 divided by A. Okay, and I will substitute for t over here and I will substitute for At over here. Okay, so see, what do you get? S is equal to V0 plus half of, you have At, which is Vt minus V0. Okay, so it is Vt half of Vt minus V0. Alright, and t is Vt minus V0 divided by A. So it is Vt minus V0 divided by A, right? Okay, after that, this is half of Vt minus half of V0. So you have one V0 minus half V0, that is half V0, right? So you are left with half of, half I can take common, V0, Vt plus V0 or V0 plus Vt multiplied by Vt minus V0 divided by A. And now you can take this 2A on left hand side, and then this is like A plus B multiplied by A minus B, so which is A square minus B square. Okay, so 2 times A multiplied by S is equal to, okay, Vt square minus V0 square, and from that you get Vt square equals to V0 square plus 2 times A multiplied by S. So this is your third kinematic equation of motion. Okay, and this is simple way to derive it, right? Let us see the Galileo's law of odd numbers for uniformly accelerated motion. What is that? So let's say there is some body in acceleration. In Galileo's times, those bodies where the body is under free fall. So what is free fall? If you release some body, okay, and if you let it fall under the gravity only, there is no other force, then that body is said to be in a free fall. Okay, so if you release, let's say, an object from some height, then it is in uniformly accelerated motion, right? It's uniformly accelerated motion, and that acceleration is because of what? Gravity, which is 9.8 meters per second squared. So now you release that ball, so distance covered by that ball in, let's say, first second, then in second, and in third second, and so on and so forth. If the height is sufficient, then those distances are in the ratio of 1 is to 3 is to 5 is to 7, so on and so forth. Okay, so you got the law. This is law of odd numbers: 1, 3, 5, 7, etc., etc. Okay, so the distances covered, in equal times t1, t2, t3 by a body performing uniformly accelerated motion are in the ratio 1 is to 3 is to 5 is to so on and so forth. Okay, so these are in the ratio of odd numbers, right? 1 is to 3 is to 5 is to 7, and so on and so forth. So that time can be anything. The time can be 1 second, it can be 2 seconds, it can be 5 seconds, it can be 1 hour, or anything. Okay, so t1 is 1 second, then t2 has to be 1 second, right? T3 is also equal to 1 second. So this is the Galileo's law of odd numbers. Okay, so is it clear? The law is clear?
Yes, sir.
Yes, sir.
Okay, so now we will not prove this. Do you want me to prove this? Yes, no?
No, sir.
Yes or no?
No need, sir.
No need? Okay, so let's solve some problems. I'm sorry. So let's solve some problems based upon uniformly accelerated motion. So this first problem: a ball is thrown vertically downward with a velocity of 20 meters per second from the top of a tower. Okay, it hits the ground after some time with velocity 80 meters per second. The height of tower is. Now I want you to tell me the kinematic equation of motion that will solve this problem. This is from NEET 2020. You have final velocity, you have initial velocity, you have acceleration.
V is equal to U plus 80.
No. We want to find out
B
the
square
height.
equal to U square plus TBIS.
Right. Okay. So see, the ball is dropped from this height, it reaches the ground, and this is the height. It is released with some initial velocity u. It falls on the ground with some final velocity v, and it's moving downwards. Acceleration due to gravity is also downwards. Okay, so your acceleration is positive, right? The movement, sorry, the displacement and acceleration, they are in same direction. So you will take acceleration as positive. So this formula, v square equals to u square plus 2 times a multiplied by s, or we used vt square equals to v naught square plus 2 times a multiplied by s. Okay, so here s is equal to this height, and we are asked about the height, right? So we get, okay, we substitute a equals to what? G, and s equals to, sorry, s equals to h. Okay, so v square equals to u square plus 2 times g multiplied by h is what we get. Then we can take u square and 2g on the other side. So we get h is equal to v square, and this u square will become minus u square on other side, and 2g will go into the denominator. Okay, so 2gh is equal to v square minus u square, and I will move 2g also on other side, so it goes to the denominator. Okay, and it's given that g is equal to 10 meters per second squared. So what is v? It is 80 square minus 20 square divided by 2 times 10. So tell me, what would be the answer? You can take 10 common from these two, so it will be 10 square 100. So what are you left with? 8 square is 64 minus 2 square is 4 multiplied by 100, okay, divided by 10, 20 actually. Okay, so if you divide by 10, this 2 times 10, okay, so this you are left with 10 over here, okay, and then 10 by 2 is 5, or 64 minus 4 is 60, and 60 divided by 2 is 30, 30 multiplied by 10 is 300. So your answer is 300 meters, right?
Yes, sir.
Yes, sir. Sir, when we take acceleration as negative, sir.
When the velocity and acceleration are in opposite direction. So let's say you throw the ball vertically upwards, okay, so velocity is upwards, the ball is moving upwards, and the acceleration is downwards, right? The earth is attracting that ball, so acceleration is downwards, velocity is upwards. So you will take, if you take velocity positive, acceleration would be negative.
Okay, sir.
Okay, so if acceleration is in same direction as that of velocity, you will take it as positive. If it is in opposite direction of velocity, you will take it as negative. Okay, simple convention. Let's move on to the next problem, and this is what I was saying. A stone falls freely under gravity. It covers distances of h1, h2, h3 in first 5 seconds, next 5 seconds, and next 5 seconds respectively. The relation between h1, h2, h3 is. So here we can apply Galileo's law of odd numbers. First 5 seconds, next 5 seconds, and next 5 seconds. What will be the ratio? So h1 is to h2 is to h3 is equal to what? 1 is to 3 is to 5. Right? This will be the ratio.
Yes, sir.
Using Galileo's law of odd numbers. Distances covered by a body in equal intervals of time. Which body? Which is performing uniformly accelerated motion. So those distances are in the ratio of 1 is to 3 is to 5 is to 7 and so on. Okay. But now what are we asked? The relation between h1, h2, h3 is. What is the relation between h1, h2 and h3? Okay. So now I can write, see, h1 is to h2 equals to what? Or I can write this as a ratio. Okay, by ratio I mean quotient. So h1 divided by h2 will be equal to 1 upon 3, and therefore I can say that I can take this h2 on the other side. So h1 is equal to h2 divided by 3, and similarly I can write that h1 upon h5 equals to what? 1 is to 5, right? It is 1 is to 5. So I can take this h5 on, sorry, it is h3, okay? h1 divided by h3, so I can write h1 upon h3 equals to what? h1 upon h3 is 1 divided by 5. So it is 1 upon 5. I can move h3 on the right hand side, it goes to the numerator. So h1 is equal to h3 divided by 5. This is what I get. Okay. So h1 is equal to h2 divided by 3, and it is h3 divided by 5. Simple. So this is the answer. Right?
Yes, sir.
Okay. So yes. So see, you have 1, 2, 3. Okay. Okay. No other option makes any sense, and I guess you will not be tempted to write any other answer because there is no 1, 3, 5 anywhere. Okay. Right. So I was checking
Yes, sir.
if there is some option where h1 is equal to 3 times h2 is equal to 5 times h3. So this is definitely not correct. So I was checking whether there is any option like that. Okay. So yes, this is simple provided you know Galileo's law of odd numbers. Okay. Otherwise you can find it. Otherwise there it will take lot of time. If you don't know this law, it will take lot of time to solve these kind of questions. Okay, so let's move on to the next question. A boy standing at top of a tower of 20-meter height drops a stone. Okay, assuming g equals to 10 meters per second squared, the velocity with which it hits the ground is. This is very simple. So you are given that boy drops a stone. So u is equal to 0. We don't know. We know the height of tower. It's 20. Okay, and g is given, which is 10 meters per second square. Tell me the kinematic equation. Which one?
V square is equal to 2as.
Yes, v square equals
Answer is
to,
40.
you found the answer also. U square plus 2as. Okay, and I want velocity only. And u is 0, so it is 2 times g multiplied by h. So 2 multiplied by 10 multiplied by h is how much? It is 20. So this is 400, and I want v only. This is v square. So I will take square root.
20.
It is 20 meters per second. This is the answer. Option B. Right. So simple. This is a neat problem. Okay. This is a lottery. Right.
Yes, sir.
Yes.
And there have been lots of questions on uniformly accelerated motion. Okay. So see, this is another question. A ball is dropped from a high-rise platform at t equals to 0 from rest. After 6 seconds, another ball is thrown downwards from the same platform with the speed v. Two balls meet at t equals to 18 seconds. What is the value of v? Okay, so how to solve this? A ball is dropped from a high-rise platform at t equals to 0 starting from rest. After 6 seconds, another ball is thrown downwards from the same platform, okay, with speed v. The two balls meet at t equals to 18 seconds. What is the value of v? So this is simple. See, a ball is dropped, okay. So first ball, it, let's say for first ball you can write s1 is equal to, no, okay, second ball is dropped after 6 seconds. Okay, so can I say S1 is equal to ut plus half of at square? Okay, let's call it u1t plus half of g multiplied by t square.
Yes, sir.
Okay, so let's call this t1, and for second ball it is, the distance will be same. Okay, so distance covered will be same. It is u2 times t, but this time will be how much? So first ball is dropped, and 6 seconds after that the second ball is dropped. Okay, so let's write it as t2. So u2 times t2 plus half of g multiplied by t2 square. So you can equate these two. Right, because distance covered by both the balls will be same if they are meeting at any time. Okay, so I can write that Okay, first ball is dropped, then it is just dropped. Okay, it has no initial velocity. And second ball is dropped with speed v. Okay, second ball is thrown with speed v. Okay, so u1 is equal to 0. So in this first case, okay, in equation 1, let's say u1 is 0. So this is just half of g multiplied by t1 square. Okay, so I can say half of g multiplied by t1 square is equal to u2 multiplied by t2, and u2 is what we have to find out, plus half of g multiplied by t2 square. And now we can substitute the values. So what are the values? Half of g is 10, t1 is how much? It is 18 seconds. Okay, starting from t equals to 0 to t equals to 18. So t is equal to 18 seconds. So 18 square is equal to u2 times t2. So u2 is v multiplied by t2. Now second ball is dropped after 6 seconds. So it is 18 minus 6. Okay,
12 seconds.
12 seconds. So v multiplied by 12 plus this is half of g. So it is half of 10. 5 multiplied by what? t2 square is 12 square. Right. And now this is very simple. So let's move this thing on the left hand side. So 5 we can take common. It is 18 square minus 12 square. Okay, let's add a page, or let's do the calculations over here. Okay, so it is what? 12 times, sorry. So 12 times v is equal to 5 multiplied by 18 square. Let me add a page. Oh, what was that? 5 multiplied by 12 square, no? 12 square. So I can write 12 times v is equal to 5 multiplied by 18 square minus 12 square. Okay. So do you know square of 18? 18?
324.
324. And 12?
144.
144. Okay. So this is 12 times v. So v is equal to 5 multiplied by 324 minus 144. So is it 180? I think it is 180.
Yes, sir.
Divided by 12.
Yes, sir.
So what is that? So 180 divided by 12. So we can divide by 6. So if I divide by 6, so this will be how much? 30. 30 divided by 2. Right? It will be 30 divided by 2. That's 15. 15 times 5 is 75.
75.
Okay, 75 meters per second must be its velocity. Yes, option A is the answer. So simple.
Yes, sir.
Yes, sir.
Okay, I'm going to leave some problems for you. Right? So I have
Okay,
lots
sir.
of problems. I'm going to leave some problems for you. Next problem. A particle starts its motion from rest under the action of constant force. If the distance covered in first 10 seconds is s1 and that covered in first 20 seconds is s2, then tell me what will be the ratio? Apply Galileo's law of odd numbers.
1:3. So,
Sanjay?
Yes, sir. 1:3.
Okay. See, Galileo's law of odd numbers says that distance is covered, let's say, okay, in first 10 seconds, distance is covered. How do I write it? Okay, so distance covered in first 10 seconds. So from 0 to 10 seconds.
Sir, answer is second option, sir.
Okay, answer is second option. So you calculated it, or you are just saying that answer is second?
Sir, calculated, sir.
Calculated, no? Yeah, that's correct. Okay, so distance covered in first 10 seconds. S1, okay, is to distance covered in next 10 seconds. So now this is, okay, distance covered in next 10 seconds. So let's write it as, okay, so S in time t1 is to S in time t2. It is equal to how much? It is 1 is to 3. Okay, so S in time t1 is distance covered in first 10 seconds. S in time t2 is distance covered in next 10 seconds. Okay, and this ratio is 1 is to 3. That means this S t2 is equal to 3 times S t1. But you want distance covered in time 20 seconds, that is t1 plus t2, right? So your t1 is equal to 10 seconds and this t2 is equal to 10 seconds, and you want distance covered in what? Distance covered in 20 seconds. This is S2. Okay, so S2 is equal to distance covered in first 10 seconds plus distance covered in next 10 seconds. So ST1 plus ST2. So that's equal to what? ST1 plus 3 times ST1. That is equal to 4 times ST1, or 4 times S1, you can say. So this is the answer, option B. Okay.
Yes, sir.
So reading the question properly, understanding the question is important. So sure, it is based upon Galileo's law of odd numbers, but there is a catch. So they are saying 20 seconds, not next 10 seconds. Okay, so it is first 20 seconds. That means distance covered in first 10 seconds plus distance covered in next 10 seconds. Total of that. Right? Simple?
Yes, sir.
Okay.
Yes, sir.
Let's see next question. A particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meters per second to 20 meters per second while passing through distance of 135 meters in t seconds. The value of t is. This is from NEET 2008, and very simple question. You tell me how to solve.
S equal to ut plus half at square.
Okay, you are given that it changes its velocity from 10 to 20 while passing through this much distance. So velocity is changing. Okay, initial velocity is given, final velocity is given, distance is given. That means you have to use which formula? S is equal to ut plus half at square. Is that the formula? Okay, first of all, you need to find out. See, if you use S is equal to u times t plus half of a times t square, you can use this formula. There is no issue, except for you don't know the acceleration. Do you know the acceleration? You don't know,
No, sir.
right? So you have to find out the acceleration first. So v square minus u square equals to 2 times a multiplied by s. So that means I want acceleration, which is v square minus u square divided by 2 times s, and it is 20 square minus 10 square divided by how much? So 20 square minus 10 square divided by 2 times 135. Okay, whatever it is. So it is A is equal to 20 square is 400 minus 10 square is 100. So 300 divided by, okay, divided by what? 2 times 135. Let's keep it as it is. Okay. And now you know the initial velocity, you know the final velocity, and you know the acceleration. You want time. So will you use this equation or will you use first equation? V equals to U plus AT.
First equation.
First equation. You can use this one also because you know the displacement. But here square is involved. So you have to solve a quadratic equation. So doesn't make any sense, right? If you can solve it simply, then there is no need to solve a quadratic equation. Okay, so V equals to U plus AT. That means, okay, T is equal to, or acceleration here itself, I can write it as V minus U divided by T. Okay, so what is V and what is U? So it is 20 minus 10 divided by T. 300 divided by 2 multiplied by 135. All right, so this is 10. So you can cancel out this thing. So 1 will remain here with this thing. So 30 divided by 2 multiplied by 135. And therefore T is equal to what? It is 2 times 135 divided by 30. Okay, and here too you can cancel out this 2 with 30. 15 will remain. Okay, 2 ones are and 2 15s are, or 15 twos are. So 135 divided by 15 is 9. 9 seconds is the answer.
Yes, sir.
Okay, so this is simple, slightly lengthy.
Yes,
Yes,
sir.
sir.
Okay, it is slightly lengthy, but you should attempt this kind of problems. Okay, this doesn't take much time, right? This is short. Okay, 4 marks. All right, so let's move on to the next question. The distance traveled by a particle starting from rest and moving with acceleration of 4 by 3 meters per second square in third second is. Distance traveled by a particle starting from rest and moving with acceleration of 4 by 3 in third second is. So what do we have to do here?
S is equal to ut plus of at square.
Okay, let's use S equals to
U
U
is equal to 0.
half AT square. Okay, U is equal to 0. That's good. So it is just half of AT square. Then shall I put A and T equals to 3 seconds? Yes, no? Okay, see, this is simple. They are asking distance covered in third second. Okay, so definitely you are hesitating because you know that if you put A, which is 4 by 3, and T equals to 3 seconds, then you will get distance covered in first 3 seconds, right? You will not get distance covered in third second. So what will you do to find out that? So let's say the body starts from here, okay, and in 3 seconds it moves till here. So this is, let's say, distance covered in first second. Okay, so distance covered till second is this much, s2, and distance covered till third second is this total distance. Okay, so what will be distance covered in third second? It will be this much distance, which is s3 minus s2. So distance covered in 3 seconds minus distance covered in 2 seconds will give you distance covered in third second, right?
Yes, sir.
Right, Sanjay?
Yes, sir.
Okay, so you can write that s3 minus s2 is what you have to find out, and that is equal to half of a multiplied by t3 square, let's call it t3, minus half of a multiplied by t2 square. Okay, so that is half of 4 by 3, and I will take that common. Okay, half a I am taking common. It is t3 square minus t2 square, which is what? 3 square minus 2 square. Okay, so this is equal to 4 by 2 is 2, 2 by 3 multiplied by 3 square is 9, 4 square is 2 square is 4. So 9 minus 4 gives me 5. So 5 multiplied by 2 by 3. So it is 10 by 3. So 10 by 3 meters is the answer. Yes, option A is the answer. Simple?
Yes, sir.
Yes, sir.
Okay. So let's solve another question. Two bodies, A of mass 1 kg and B of mass 3 kg, are dropped from heights of 16 meters and 25 meters respectively. Okay, one is dropped from 16 meters, another one is dropped from 25 meters. The ratio of time taken by them to reach the ground is, this is simple. So does the velocity or acceleration due to gravity, does it depend on the mass?
No,
Yes,
sir.
sir.
They will experience same amount of acceleration, right? Which is 9.8
Yes, sir.
meters per second square, and we'll take it as 10. Okay, we'll take it as 10 approximately. So the ratio of time taken by them to reach the ground. Okay, so first one is dropped from the height of 16 meters. So we know the h1, okay, is 16 meter. It is just released from that height. Okay, it is not thrown with any velocity. It is half of g multiplied by t1 square, and h2 is equal to half of g multiplied by t2 square. Okay, so you can take the ratio of these two. So this h1 upon h2 will give me t1 by t2 square, and then I will take square root on both sides. So I will get t1 by t2, t1 divided by t2, square root of h1 upon h2, and that is 16 divided by 25. So it is
4 by 5.
4 by 5. 4 by 5 is the answer. Okay, simple.
Yes, sir.
Okay, so if you
Yes, sir.
remember a formula over here, what is the formula? So let's say time taken by an object which is released, which is under free fall, which is released freely under gravity, okay, to reach on the earth is t. Then you can write the height is equal to what? Half of g multiplied by t square. Okay, so you take that half and g on the other side, so you will get t square is equal to 2 times h divided by g, and then if you take square root of that, you will get t equals to what? Square root of 2h divided by g. Okay, so if you remember this
Yes, sir.
formula, it will be simpler to solve. Okay, so time taken by a body under free fall to reach the ground, it is t, it's given by what? Square root of 2h upon g. So if you know this formula, t1 by t2 is ratio of what? Square root of h1 by h2 directly. Okay, because g and g will get cancelled out. So t is directly proportional to square root of h, and if you take the ratio, t1 by t2 will be just equal to what? Square root of h1 by h2. So please remember the formula. And even if you, this is very handy formula to memorize, but even if you don't remember, you can solve this very easily. Okay, simple question.
Yes, sir.
Yes, sir.
Okay, let's move on to the next question. A ball is thrown vertically upward. It has speed of 10 meters per second when it has reached one half of its maximum height. Okay, speed is 10 meters per second when it reaches 1/2 of the maximum height. How high does the ball rise? This is the question. So the ball reaches this height and it has got 10 meters per second speed. Okay, so ball is still moving upwards, vertically upwards. So this much distance they are saying is s by 2. Okay, so ball reaches some more distance, s by 2, and its speed becomes 0. Okay, 0 meters per second at that final height. And now we can use this formula. So v square equals to u square plus 2 times a multiplied by s. So which in this case is s by 2, right? So final speed over here is 0. Initial speed, since ball is moving upwards from this height, okay, it is 10 meters per second, and acceleration is minus 10. So now we get 0 equals to 10 square minus 2 times 10 multiplied by s by 2. So this thing gets cancelled, 2 and 2 gets cancelled. Okay, so 10 times s is equal to 10 square, and therefore s is equal to 100 divided by 10, which is 10 meters. Okay,